Find some patterns behind trigonometric ratios of an angle. Look at this circle that is drawn here and the two axes x and y, and let us say that the origin O is at the center of the circle, and let us label the points where the circle intersects the two axes as A with the positive x-axis, B with the positive y-axis, C with the negative x-axis, and D with the negative y-axis. Let us consider a point P on the periphery of the circle so that this line OP makes an angle of theta with the positive x-axis in the counterclockwise direction. Now, what are the coordinates of point B? We know that the x coordinate of point P is basically the length of the projection it makes on the x-axis, and the y coordinate is the length of the projection it makes on the y-axis. Let us label this point where perpendicular from P meets x-axis as A prime, and this other perpendicular from P that meets y-axis as B prime. Therefore, coordinates of P are OA prime and OB prime. Now, what's OA prime? If we assume that the radius of this circle is r, then OP is equal to r, and therefore we can see from this right triangle OA prime P that OA prime is nothing but r cos theta, because cos theta is equal to OA prime divided by r. And likewise OB prime is equal to A prime P, the height of this right triangle OA prime P, and A prime P is nothing but r sine theta, because sine theta equals A prime P divided by r. And now, for simplicity, if we assume that r is equal to 1, that is, the radius of this circle is 1, and that is, if it is a unit circle, then we can say that the coordinates of P are cos theta sine theta. Now, this is an important result because it holds true for any value of theta. That is, no matter where P is, whether it is in the first quadrant, second quadrant, third, or the fourth quadrant, the coordinates of point P will always be cos theta comma sine theta in case of a unit circle, as long as we are measuring theta from the positive direction of the x-axis. Therefore, to conclude, we can say that if this line segment OP makes an angle of theta with the positive direction of x-axis, then cos theta is nothing but the projection of OP on the x-axis, and sine theta is nothing but the projection of OP on the y-axis. And note here that the sign of these projections on the x-axis or on the y-axis depends on which side of the axis we are. So if we are on the positive side of the x-axis, this projection is to be taken as positive, and if we are on the negative side of the x-axis, it is to be taken as negative, and likewise on the y-axis, positive or negative. Therefore, now we can immediately see that if an angle alpha was such that the line OP prime, which made that angle alpha from the positive x-axis, was in the second quadrant, then sine alpha would be positive because the projection of OP prime on the y-axis is positive, whereas cos alpha would be negative because the projection of OP prime on the x-axis is on the negative side. And if there's another angle beta, something like this, which this line segment OP double prime makes with the positive x-axis, then both cos beta and sine beta would be negative, because we can see that the projection of OP double prime on the x-axis is on the negative side, and its projection on the y-axis is also on the negative side. And similarly, if there's an angle gamma such that this line segment OP triple prime that makes it from the positive x-axis lies in the fourth quadrant, then cos of gamma would be positive because the projection of OP prime on the x-axis is positive, whereas sine of gamma would be negative. Now, with this understanding, we can easily get a sense of the direction of sine or cosine of various angles and even find out the values of some of those angles. Now, let us try to summarize our learnings here. For different values